Okay, we are going to start with systems of equations word problems, and there's many different kinds. We're going to start today with two different kinds, and I'm actually going to make this in two different videos. The first video will be the rate times time equals distance that we see on our screen right now. The second video is going to be rate times time equals work, and it will be a much shorter video. So let's look at some of these examples that we have right here. One distance equals the other distance. So these are examples of types of setups of word problems that you might see. So in this first example, you have two people starting at the exact same spot. They are traveling the exact same distance. So they're headed to the same spot. Maybe one person's going faster than the other one, but they both arrive at the same destination. In the second example, usually this is one person going to work and returning in the same path, going to school and coming back. But it's one person traveling the same distance there and back. The second type of problems that you have is where you have distance 1 plus distance 2 equals the total. So let's look at this first example. Let's say a guy starts on a business trip. He drives a certain distance and he has to stop and sleep for the night. And then he gets up the next morning and he heads out until he finally gets where he needs to go. This is the total distance that he traveled. Distance 1 would be his first day. Distance 2 would be his second day. So in this next one, these are two separate people heading towards each other. This is still a total. This is the distance of the first person, and this is the distance of the second person. And together, that equals the total distance. In this last example, these are the same people heading, these are two different people heading in opposite directions. This is distance 1, this is distance 2, and at some point in time, they're distant. We're going to stop the time. We're going to say, how far apart are these people? So they've traveled the same amount of time. We just need to know how far apart they are. So let's look at our first example. So we're going to mark up and make sure that we get everything underlined and circled that we need to know to make sure we fill out our charts like we should. So first person is Melanie. She left the city traveling at 58 miles per hour. Well, at the same time, Jessica left the city going in the opposite direction at a speed of 51 miles per hour. Find the time that Melanie traveled before the two were 199 miles apart. So let's draw this picture. They both started in the city. One of them headed one direction. One of them headed the other direction. So let's call this first one Melanie. We'll call the second one Jessica. And we know that at some point in time, they were 199 miles apart. So on our chart, we have Melanie and we have Jessica. Rate means miles per hour, inches per second, kilometers per hour, something like that. So Melanie's rate is 58. Jessica's rate was 51. They have traveled the same amount of time. They both left. Melanie's obviously traveling faster than Jessica, so Melanie has gone farther, but the amount of time that has passed is exactly the same. So if we look at this title right up here, it says rate times time equals distance. So if I take 58 times t, I get my distance. And for Jessica, I would take 51 times t to get my distance. So according to this example right here, distance 1 plus distance 2 equals the total distance. Well, distance 1, we'll call that Melanie, is 58t. I got that information right here. Distance 2 is Jessica. She was 51t, so I got that information right here. And that equals the total distance of 199. Now this is just a regular equation that we can solve. We add like terms. So 58t plus 51t is 109t, and that equals 199. Divide both sides by 109. That makes invisible 1. The time, and we're going to use decimals, 1.82 hours. Now, once we get all the information, it's actually not that difficult. So let's look at another problem and see what we can come up with. John left home and drove at a rate of 45 miles per hour for 20 hours. He stopped for lunch, then drove another 3 hours at the rate of 55 miles per hour. How many miles, so that's distance, did John drive? So let's look at our sketch of this. So John left home, drove some distance, stopped for lunch, drove another distance. So that is also a total distance problem. So this was before lunch. This was after lunch. And you can call it whatever you want. So we will have before in our table and after. So before lunch, he was driving at a rate of 45 miles per hour for 20 hours. And then after lunch, he drove for 3 hours, 55 miles per hour. Rate times time equals distance. So 45 times 20 is 900, and 55 times 3 is 165. We know that this is a distance 1 plus distance 2 equals a total. Now they're asking us how many miles. They're asking us for the total distance. So the distance 1 is 900 plus distance 2 is 165 equals the total. So that's 1,065 miles for our total. Okay, so let's look at the next problem. Okay, this one, a train leaves the station at 1 p.m. At 1 p.m. It travels an average rate of 60 miles per hour. A high-speed train leaves the same station an hour later. It travels an average of 96 miles per hour. The second train follows the same route as the first train on a parallel track. So follows the same route. In how many hours will the second train catch up with the first train? So here's what happened. The first train left, and then the second train, the high-speed train, left and caught up with it. So this is the train. This is the high-speed train. So according to our chart on the page before, that's distance 1 equals distance 2. So let's use a T for train and an HST for high-speed train. The regular train travels at 60 miles per hour. The high-speed train travels at 96 miles per hour. It's asking us in how many hours will the second train catch up with the first train. So we're going to make our second train T. Now the first train left at 1. This high-speed train left an hour later. So that means this train, the regular train, had 1 extra hour of travel before the other train left. So we'll make that T plus 1. So we know rate times time equals distance. So 60 times, so let's use parentheses, t plus 1, and then 96t. Well, if distance 1 equals distance 2, we put our first distance here and our second distance here. Then we need to follow our order just like we would in solving equations. So in this situation, we have a distributive property. So 60t plus 60 equals 96t. We don't have any like terms to combine. And I'm actually going to take my letters to the right this time. So I subtracted 60 from both sides. So I have 60 equals 36t. We'll divide both sides by 36. And remember, I said it's okay if we use decimals in this. And t is going to be 1.7 hours. And we wanted to make sure that we found the time of the second train. The second train is t. So we're done. We don't need to substitute that back in. Okay, one more example. Noya drives into the city to buy a software program at a computer store because of traffic conditions. So Noya into the city. Because of traffic conditions, she averages only 15 miles per hour. On the drive home, she averages 35 miles per hour. If the total time is 2 hours, how long does it take her to drive to the computer store? How long? Okay, so let's see what's happening. She leaves her home, she drives to the computer store, then she gets in her car and she comes back home. So according to the chart that we had at the beginning, this is a distance 1 plus distance 2. Nope, how about equals? Distance 1 equals distance 2. So she went there, she went to the store, and then she came back. Going into the city or going to the store, she drove 15 miles per hour. On the return trip, she drove 35 miles per hour. The total driving time is 2 hours. We want to know how long it takes her to drive to the computer store. So we want to know the time there. So we're going to make that t. We know that it took them 2 hours total. So that means coming back had to be 2 hours minus the time it took to go there, because the time there plus the time back equals 2 hours. So rate times time equals distance. So that's 15 times t and 35 parentheses 2 minus t. And distance 1 equals distance 2. So 15t equals 35 parentheses 2 minus t. Oh dear, that was ugly. Let's try that again. Distributive property. So 15t equals 70 minus 35t. Let's add 35t to both sides. So that's 50t equals 70. Divide both sides by 50. And t equals 1.4 hours. All right, you can take a short break and then you need to come back and you need to finish this with video 2.